What's up, math enthusiasts? Welcome to my YouTube channel. Make sure you subscribe for all the hottest updates on mathematics. All right, here we go. Video 6, percentile and z-score. Let's get started. What is percentile? Well, let's say that 100 people took a math test, all right, and they all lined up from here to here, right? We've got little Johnny in the middle who took his math test and he got a 77. And then little Sally, she studied extra hard and she got a 91. And then someone cheated on their test and they got a 95. All right, so we've got 100 people all lined up. Now, what is percentile? Okay, let's say that little Timmy, Tom, Benny boy scored, I don't know, let's go with an 89. And again, 100 people. And let's say Timmy, Tom, Benny boy scored better than 63 people. If Timmy, Tom, Benny boy scored better than 63 people, that means that Timmy, Tom, Benny boy is in the 63rd percentile. That's what it means. So just quick question here. Would you rather be for SAT scores in the 95th percentile? Or would you rather be in the 3rd percentile? Well, of course, you would rather be in the 95th percentile because that means essentially you have scored higher than 95% of the population. If we lined up 100 people who took the SAT score, in theory, you would be better than 95 people, which is much better than out of 100 people being better than just 3 of them. So quick question for y'all. Is it possible to score above the 100th percentile, or even can you be 100th percentile? The answer is simply no, because you have to think about being better, right? Can you be better than 100%? Well, not really. If you had 100 people lined up and there were 100, you were the 100th person. You could only be better than 99 of them. Okay, so we cannot be above 100, nor can we be 100. The best you can be is 99 percentile. Or if you're doing decimals, maybe 99.999 percentile. All right, now we're going to calculate percentile. And let's go ahead and let's look at the instructions here. So to calculate the kth percentile, so k means something like, in this case, the 90th percentile, our k is going to be 90. We're going to order all the values in the data from smallest to largest. Have we done that? Why, yes, we have. So we're already really done with steps 1 and 2. Or actually, step 1, excuse me. Step 2 says multiply k% by the total number of values of n. Well, we can go ahead and count these all up, all of these values here, but I'm going to go ahead and tell you that we have 25 values, okay? So to do step 2, we're going to multiply k by the total number of values n, and you should know that if I'm talking about the 90th percentile, right, we've already done step 1, if we're talking about the 90th percentile, we're going to take 0.9 and represent that as 90. All right, we're going to take 0.9, that's our k%, and we're going to multiply it by the total number of values in n. In this case, we have 25 values. So 0.9 times 25 is going to give me a 22.5. Sweet. All right, let's go ahead and let's go to step 3. Let's read that carefully. That says if the index, okay, our index being 22.5, in step 2 is not a whole number, round it up to the nearest whole number and go to step 4a. All right, let's do it. So on this here, we are going to go step 3. We're going to round that up to the nearest whole number. And make sure you're rounding up. You're not rounding properly, you're rounding up. So now we are making sure that we're rounding to 23. Okay, now we have to now go to step 4a. So let's go back to step 4a and see what that says. Okay, step 4a says, count the values in your data from left to right, from smallest to largest, until you reach the number it indicated in step 3. The corresponding value in your data set is the kth percentile. What does that mean? That means I need to count from all the way here, let me put my laser up, from my first term all the way up to my 23rd term to find what my 90th percentile is. Or I could be smart and not count from 1 all the way up. I can say, oh, this is my 25th, this is my 24th, and 98 here is going to be my 23rd. Okay, so we have our answer. This is our 23rd term. We go to our 23rd term here, and our final answer here is that the 90th percentile is going to be the same as scoring a 98 on this test. Okay? All right. That's how you do that. That's the 4A. Now let's go ahead and do one where we're going to have to use 4B. All right. Well, we've already ordered the values from smallest to greatest, so we're done with step 1 here. Step 2 says to multiply my percentage, or K, 0.2 by 25. And here, I'm going to get a whole number. I actually get just plain old 5. Okay? So in this case, I need to read my 3 here. It says, if the index obtained in step 2 is a whole number, go to step 4B. So step 4B says count the values in your data set from left to right until you reach the number indicated by step 2. In that case, I'm talking about 5. 1, 2, 3, 4, 5. I'm talking about this one. The kth percentile is the average of that corresponding value, in this case 62, and the value that directly follows it. So we're talking about averaging 62, which is the number we get from the 5, but not only that one, we're going to average it with the next one, the data set, the data value that directly follows it. So now I'm really on step 3 that tells me that, hey, 5 goes to step 4B, and my step 4B tells me to average 62 and 66, add those up, divide them by 2, and you do get 64. So what did we find? We found that if you scored in the 20th percentile on this test, you scored a 24. Meh, not so good. If you scored in the 90th percentile, you scored a 98. That's pretty good. All right. Let's now talk about percentile and the z-score. So the average calorie consumption at lunch is 500 calories, and the standard deviation is 100 calories. If Tucker is in the top 10% of food consumers, how many calories would he have to consume at lunch? Wow, this is a lot of information here. The only different thing in this situation is that I gave you a percent, and it's actually not percentile. Be really careful. It says if Tucker is in the top 10% of food consumers. Well, ladies and gentlemen, what does that mean, being in the top 10%? It actually means that he's in the, he's in the 90th percentile. And if we look at this handy dandy chart, we can say that that z-score with 90th percentile, it's not perfectly accurate. Oops, shouldn't have highlighted that. Is a 1.3. Okay, so that's important. And I also need to know what the standard deviation is. You can see if I want to find how many calories Tucker has to consume, that's my x. My z I have, my standard deviation I have, it's 100. Do I have my x bar? Yeah, I do actually. Look, it's given to me right here. The average is 500. So my X, the amount that Tucker has to consume at lunch to be in the top 10% or to be in the 90th percentile, is going to be my Z-score, which is 1.3. How'd I find that? From the chart, times my standard deviation of 100. Got that in the problem right here. Plus my average, which is 500. Now, what is this going to end up being? This ends up being, quick math in my head, 130 plus 500 is 630 calories. Way to go, Tucker. That's a good amount of food for you, buddy. All right. That's really it for video 6. The next video is going to be on outliers. Thanks for listening. I really appreciate my fans. You're true, you're loyal, you're smart, you're great. All right, have a great night. Bye-bye now.